Okay, started the recording. Mm. So, second. Okay, so let me share my screen. Then we can start. So, in the previous session, we were going through about this log files, right? IBD, file IB data one, and this dictionary, SDI files, how to get the data from SDI files. So all these things we gone through in the last session. So yeah, we will start from here. This will come under the InnoDB architecture. Hmm. So for 1 second, let me. Okay. So this is the data directory, right? So these are the files inside it, right? So fine. So we are already aware of these folders or the each databases, right? For every database, we have the dedicated folder. Apart from that, we have two more folder. This is for the redo logs, and this is for the temporary files. Okay. So first, so we have inside this data folder, we have redo log, undo log, right? Temporary table spaces, and apart from that, we have the data files and the system table spaces, then the perm files that will be by default created whenever you uh, install and restart. Even the restart MySQL, it will be automatically created. You can use it for your SSL configuration, all these things. Okay, uh, fine. So let's see what is the purpose of this redo log, undo log, and the related parameters. How I mean, what is the role of those files, the system related files in the um in the MySQL, I mean daemon process. Okay, that we will see. So we already aware MySQL is the complete uh asset, right? Atomicity, consistency, isolation, and durability, right? So which means like that is the transaction safe database, right? Um, so here, this is the diagram from the MySQL official page, documentation page. So this is the in I think the last session or the previous session we see about different engines, and I also shared one blog, and I mostly 99 percentage we are using the InnoDB engine. So we need to get familiar with the InnoDB engine. Okay, so we need to understand the parameters. We need to understand the best practice. Moreover, we need to understand the architecture so that we can tune it, right? So once we know about it, then we can do something on that, right? So uh, in this session, we will try to cover the InnoDB architecture and the pending files. Okay, so when I am going through this InnoDB architecture, I will also relate that with the physical files located in the data directory, so we can complete both together. Okay, fine. So I to explain this, what I am thinking is I can create like a, let's say we can try to understand the flow. For example, there is a update statement. Okay, update statement. I am trying to update one table. For example, update for T1 table. I am set some name equal to some value. Okay, where ID equal to 10. So I am running this update statement. While running this update statement, what happens in the engine? Okay, what happens in the engine? So that is what we are going to understand the flow, the transaction, how it happens internally, the engine. Okay, so if you see this architecture diagram, it has two major part. Okay, two major part. One is in memory structure, and another one is on disk structure, right? And in between in memory and on disk, we have the operating OS cache, right? OS cache we have in between the in memory and on disk. Fine. And if you see on disk structure, all are the files. Whatever you are seeing in your data directory, that all the files are exist. Mostly all the files are exist here in the on disk structure. In memory, there are few components that we need to understand what they are doing, that we need to understand. Okay. So this is the flow. When you are trying to optimize your MySQL, your MySQL is running on InnoDB engine. So you need to optimize the InnoDB related parameters. That is main thing. So first you need to aware of those parameters, and what is the role of those parameters, so you can optimize it, right? Fine. Now coming back to this, we have this update statement. The update statement is I am trying to update the T1 table. I think T1 is already here. Yeah, T1.ibd. I'm trying to update this T1 table. I'm updating one of the row where ID equal to 10. That particular row I am trying to update, okay, on the T1 table. So when I started the when once you created the update statement, after that you are trying after when you hit the enter, what happened? It will go through the logical architecture first. So we see in the previous session, right? It will go through the parser, optimizer, all this thing. Parser will validate the SQL syntax, authentication, whether the user have the access to execute the query or not. Once the parser part completed, it will come to the optimizer. Optimizer will create the plan to execute the query in the optimal way. So once all these things, once it cross the logical layer, it will comes to the engine. Okay. When it comes to the engine, first it will enter into the memory, in memory structure. Okay. So we have the buffer pool. Buffer pool is the global memory area that usually we allocate 60 to 70 percentage of your RAM. If in case if your server is dedicated to MySQL, okay, you should run your MySQL only run the MySQL on the server. So that is the dedicated server for the MySQL. In that case, you can set it up some kind of 60%. I prefer 60 until it is necessary to increase further. But mostly for the optimal environment to avoid any kind of memory leak, memory kind of issues, mostly 60% is pretty fine. Okay. But if you are lagging, your queries are lagging due to the memory thing, then you may consider increasing further. Okay. But yeah, make sure your environment is completely dedicated for the MySQL. In that case, you can definitely go to 60 to 70% of your, you can allocate the memory to the buffer pool. Okay. So we have the parameter InnoDB underscore buffer underscore pool underscore size. That is the parameter. You can use it to set the buffer pool value. Okay. So yeah, let's see the variables later. So when the query comes to the buffer pool, when it comes to the engine, first it will meet the buffer pool. Okay. In the buffer pool, I am trying to update the row ID equal to 10 on the T1 table, right? So in the in the table space, it have a lot of pages. Pages have segments, all these things, right? Segments, pages, right? In the InnoDB, by default, InnoDB page size is 16 KB. That also you can control with the parameter InnoDB underscore page underscore size. That is the parameter. By default, the page size is 16 KB. Okay. Let's say the ID equal to 10, that is one row. That row should be stored in the table space. Within the table space, any of the page, it will be stored. Right. See, this is the t1.ibd. You can see these lines, right? So these are all the, let's consider these are all the pages. Okay. Let's say my ID equal to 10 is located in this page. So this page needs to be modified, right? I am changing the value for the ID equal to 10. I am changing the value. So this page needs to be modified. So what it will do, um, it will check when the update enters to the engine layer, it will check this particular page is already exist in the buffer pool or not. In the buffer pool, you can see these are all the pages. These are all the pages from your different tables. Whatever activity, right, like a select or insert, whatever you are doing, those what are the tables are getting accessed, those pages will be available. Okay. So when the update enters, it will check any one of this page. Like it will check for that particular page which that needs to modify, that particular page is already exists in the buffer pool or not. Okay. So this is what buffer pool size is important. Okay. So when you have the good allocation for your buffer pool, it can keep lot of pages in your buffer, in your memory itself. Okay. So what happen if the page is not available here? It needs to get this page from the disk. So it will spend some IOPS on the disk. Okay. So see, if your buffer pool is very low, and if you are keep reading from the disk, then what will be the, it will impact your performance, right? So that is the reason you should keep the good amount of buffer pool. Okay, fine. Now if this page is not available in the buffer pool, then what happened? It will directly look the table space and it will get the page from the t1.ibd to here. Okay, it will get the page to the memory from disk. Okay. Once the page is available, it will modify the page in the memory. Okay, it will modify the page in the memory. Once the page is modified in the memory, that particular page will be called as a dirty page. Okay. Once the page is modified, it is called a dirty page. So currently the page is modified only in the memory. Okay. So now two things. I am changing this value name equal to AA. So previously it could be some different value, right? Maybe let's see, previously it was A1. Okay. Okay, I am starting one transaction, right? Begin. Okay, the previous value is, this is the previous value. Previous value is A1. Okay, I started the transaction and I started this update. This update, once I started, it will go to all these things and it will get the page from here and it will modify whether it is dirty page. This until this is done. Now, my engine MySQL do not aware whether I am going to commit or roll back. Commit or roll back, right? I can do any of these things. If I commit at the end, at the transaction end, I will see AA. If I roll back, MySQL should update A1, right? If I'm rollbacking this transaction, it should be A1 at the end of the transaction. But if I commit this transaction at the end of the transaction, it should be AA. So if I am rollbacking, then MySQL needs to update the older value, right? So MySQL should aware of the older value. It should keep track of the older value until the transaction is committed or rolled back. Okay. Because MySQL do not aware whether I'm going to commit or roll back. If I'm committing, it should be this. If I'm rollbacking, it should be this. So it should be tracked until this transaction comes to end with the rollback or commit, right? So this track will happen on the undo log. Okay, that is the major purpose of undo log. It will keep track the, I mean, let's say this is just one row. Let's say in your live environment, you may update or delete multiple rows, right, within the transaction. So every and different sessions, the concurrency, this everything until the transaction completed, MySQL will keep track of all the transaction and it will keep track of the before image in the undo table space. That is called the undo log. Okay, in case I'm rolled back, the before image, I mean that previous value will be get by the undo log and it will be updated. Okay, so that is the purpose of undo log. Now, my my page is now modified. My update is modified here, and this is called a dirty page now, right? When see there are multiple transactions or keep running. Okay. Now, yeah, so this transaction is completed. This is still in the memory, in memory, which means it is in the RAM, volatile, right? In case any crash or anything happens, I will lose this transaction, right? Because this is still in the memory, right? So to avoid this, MySQL will keep the transaction also in the disk. Disk means in the redo log. Redo log is located in the disk. So whenever the transaction is completed, processed, it will prepare the redo events and it will redo events will come through the buffer pool. Okay, it will come to the log buffer and log buffer will return the redo events to the redo log. When the transaction is written in the redo log, then only it will give the commit signal. Okay, so now the transaction is committed here, right? So now this is also written in the redo log. Once it is in the redo log, then only it will provide the commit signal. Now in this case, let's see this, it is transaction is in redo log and still my MySQL got crash. In this case, what happened when you do restart the MySQL again, MySQL will perform the crash recovery. It will perform the crash recovery based on the last log sequence number. It will scan the redo log and it will go through the remaining log sequence number, LSN number. And if it is committed, then it will apply the events in the actual table space. If it is not committed, then it will roll back. Okay. So this is the purpose of redo log. So undo log means it will store the previous image of the transaction so that whenever the transaction needs to roll back, the previous value will be get by the from the undo log. Redo log means the main purpose of redo log is crash recovery, which means whenever the data is processed, it will process in the memory. So if we just give the commit without written in the disk, then in case of any crash or whatever happens, I may lost my transaction. So to avoid that, MySQL maintain the read log in the disk, and whatever transactions are processed in the memory in the buffer pool, that will be written in the read log. Post that only you will get the commit signal. Okay, fine. Until this it is clear, right? Now, when it is returning in the redo log, there are we can control that actually. Okay, we have one parameter which is InnoDB underscore log InnoDB at 1 second. Let me show that. InnoDB show variables like InnoDB log at Inno transaction commit. What is that name? Class class So this is the parameter InnoDB flesh logger transaction commit. Okay. So for this parameter, we have three values. So let me explain that. We have three value, 1, 2. Okay, what it will decide. So what we know, so whenever the transaction is processed, it will return in the read log so that my transaction is safe. Whatever happens, my transaction is safe. But this can be controlled by this parameter, InnoDB flush logger transaction commit. So this has three values, 0, 1, 2. Okay. 0, 1, 2 means, let me explain. 1 means, 1 is the recommended setting. What 1 means, for every transaction, log buffer will write the transaction into the OS cache, and OS cache will do the fsync to redo log, which means every commit, the transaction is getting written into the redo log. Got it, right? So for every transaction commit, the transaction is being written to the OS cache, and OS cache will flush the do fsync the data to the redo log. So every commit will every commit log buffer is the transaction is in the redo log. So in this case, we are safe. Like because we are every commit we are writing the redo log. Okay. So the transaction loss, there is no zero transaction loss. If I have 2 means what happened, for every second it will write uh, every second OS cache will do fsync from here to here, but every transaction log buffer will write to the OS cache, which means my transaction is available in the OS cache, but every second OS cache will fsync from here to redo. So in this case, if my MySQL crash, still I have little bit I can rely on the OS because the transaction is still available in the OS cache, OS cache will take care of the flush from here to here. So this is little bit not exactly we can ensure that we are 100 percentage transaction safe, but still it is like not very bad comparing to the zero, because what happen if you set zero, for every second it will write and it will flush. It will write to the OS cache and every second it will flush, which means the transaction loss is heavy with the zero. With the one, what happened? Every second it will write and flush. Sorry, every commit it will write and flush. So your transaction is completely safe. You will not lose any transaction in case any crash or anything happen. But when you have two means, every transaction it will write, but every second it will flush, which means every transaction your MySQL doing that job. So your MySQL memory to OS memory, the transaction comes, which means your MySQL crash, still you can OS cache will take care of the pending transaction. It will flush to the right to the read log, right? But if you set it to zero, what happened? You are completely let's say if your system is completely crashed, not only your MySQL, your OS system is completely crashed, then you will entirely lose 1 second of transaction, right? But here setting to one is very like performance will be impacted, because you are spending the IOPS on every transaction, right? So that performance will be slightly lower comparing to the 2 and 0. When you set to 0, you will get very good performance, because you are not spending more IOPS. For every second only you are grouping the transaction, and the entire group you are flushing. So in that case, your performance will be good, but comparing to the transaction, like this is actually not recommended. Zero is not recommended in your OLTP environment. Okay, in case if you want to do set it on any replica for your reporting queries, just you are running something like that, that is okay. But even in your production environment, zero is not recommended. Okay, so this is what when you are having the dirty page, still you can, when it comes to the read log, you are good, but still writing on the read log, we are controlling with the parameter. So having one, you are completely transaction safe, setting to one. So that is the recommended value for your production environments. Okay, fine. So now now we cover this buffer pool, redo log, undo log, these things, right? Log buffer, these things. Now let me come to the change buffer. What is change buffer? In between the log buffer and the buffer pool, we have this change buffer, right? So let's see what is that. So in your table, you may have lot of secondary indexes, right? Secondary indexes means you might have the primary key, unique key. Apart from that, you may have created some indexes for the other columns as well, right? For the maybe based on your queries, maybe based on some other columns. So you may have some secondary indexes as well. So that secondary indexes will also maintain the page with the data, right? So what this change buffer will do, let's say if I am doing one update, yeah, let's come to the same example. I am updating the ID equal to 10, that specific update, right? So that ID column, let's consider this ID column have one secondary indexes. Let's for example, IDX, this is one of the secondary index I have for this ID column. Okay, so whenever I am updating that particular row, the relevant secondary index page also needs to be updated, right? So that my optimizer statistics will be uh, true. So whenever I'm doing the query based on that column, the optimizer statistics will be corrected. Okay, it will be maintained. So whenever I am updating that value, my relevant secondary index page also needs to be updated. But But whenever I am doing this update here, the same time if it goes to the table space and get the secondary index page for that particular row and updating here, that operation will be costly. Okay, because that needs to go to the disk. All these things needs to be done. Yeah, it needs to spend some additional IO, so that operation will be costly. So what MySQL will do, MySQL will cache all the secondary index pages modification in the change buffer. Okay. All the secondary index pages modification in the change buffer, and whenever that specific page comes to the buffer pool, that time it will merge the change to that page. Okay, so this every operations will be happens in the memory itself. It does not goes to the it does not spend some dedicated operation to update the secondary pages on the disk. It will just keep the modifications on the memory itself in the change buffer. Whenever the specific page comes to the buffer pool with the other operation, then it will just merge it. That's it. Merge on the memory itself. So it will help to boost some performance. Instead of every time going to disk, it will boost some performance. Okay, so that is the main role of the change buffer. Now now where is that? Double write buffer. Okay, so we we know like that page size is 16 KB, right? 16 KB, that is the InnoDB page size. Let's say, so main purpose of this double write buffer is to avoid the partial writes. Okay, which means, let's say now my transaction is in read log the previous transaction. So in the this dirty pages will be asynchronously flush from buffer pool to actual IBD file. Asynchronous, that InnoDB background threads will be take care of it. Asynchronously, the transaction sorry, the dirty pages will be flush from buffer pool to actual IBD file. Once it is written in the IBD file, it will remove the entry from redo log, because after that it is not needed, right? Entry in the redo log is not needed because the actual change is already committed to the table space. So then it will be remove the entry from redo log. Now now in case if my page is directly writing from here to table space, in that specific time, let's say I have 16 KB of page and it already written the 8 KB, still 8 KB needs to be written. That time, if any um, unexpected crash, OS crash or anything, power loss, anything happens, this page will be partial in the IBD file. Right? This page will be partial in the IBD file. And when the server comes up, this may corrupt the table as well, because the partial page in the in the OS level, it may corrupt the table as well, right? Because the block is not completed yet. So to avoid that, what MySQL will do, because this will see this page here, it is partial, maybe this page also removed from here, then that may the problem, right? So to avoid that, what MySQL will do, MySQL will write that 16 KB of page in the double write buffer files first. So your double write buffer files will have that 16 KB of page copy here. Then it will write into the IBD file. So in case of anything partial writes or any issues, anything happens with that specific page, that can be recovered from the double write buffer. Okay, so this is the purpose of double write buffer. So what the purpose of double write buffer is to avoid the partial writes, to recover the page from the partial writes. So MySQL will asynchronously write the data pages from the buffer pool to actual IBD file, but it will, before writing to the actual IBD file, it will have the copy of that specific page in the double write buffer file. then only it will return the IBD file. So in case this during the writing on IBD file, in case anything happened, the page still can be recovered from the double write buffer. Once this dirty page is written to the actual IBD file, then it will signal the redo log and it will remove the entry from the redo log, so that we will get the 1 second, get the space on the redo log as well. Okay, fine. Now we already see about the system table space, right? In the IB data system table space mean IB data one in the last session, that InnoDB file per table, all these things we already seen. Now, yeah, so this is actually the thing. This there are few temporary table spaces are here. IB temp one, and this all whatever we are seeing, you can see this all are available in our data directory. Okay, that's what we are seeing here. These are all the temp tables that we are going to see it, and this is about redo logs. Okay, and this is the undo logs, right? And this is the temp table we are going to see about, and this is a system table space. This is the double write buffer that we see now, right? So whatever we are seeing, that this is the on disk structure that is already we have in our data directory. Now let's see about this temporary table spaces. In the temporary table spaces, there are two major component. One is .ibt and the ibtemp1. Okay, ibtemp1 is the globally shared temporary table space, and IBT is session specific. Okay, you might see a lot of IBT files inside the folder. We will see that. And ibtemp1 is the globally shared table space, which means so IBT means in the session level, let's say if I am creating one table, like create temporary table name, some columns. In that case, like the user created temporary tables, these things will be stored in the IBT. And let's say my SQL, I'm running on heavy select statement with a lot of order by and group by some complicated operations, then it should create the temporary table. If the temporary table is fit with my temp table size value, then it should be in the memory. If it is overflow my temp table size value, temp underscore table underscore size, that is the parameter. We usually allocate 16 MB something. So if the table that created internally creating the temporary table is more than 16 MB, then it will be converted to the disk. Okay, if it is fit within my temp table size value, then only it will be in memory. When it cross that particular size, then it will convert it to the on disk, so that we will need to have the right temp table size based on our operation, because when it is converting to the disk, it will be the slower operation. Your select will be automatically getting slow, right? Fine. So this all temp tables will be stored in the IBT file, .ibt file. For each session, if there is the temp table uses there, then this each session one IBT file will be allocated. Okay, I will show that. Okay, I will show in the demo. And this IB temp one is, it is mostly the purpose of IB temp one is it will hold the rollback segments for the, let's say if I created one temporary table manually using the create temporary table syntax. I created one temporary table and I am doing some modification, deletes, all these things I am doing. So that changes needs to be cached, right? So that if those changes are needed back, that can be get from the uh, like uh, like this undo log we see, right? Undo log is for the normal table operation, but when I am doing those update or delete whatever on my temporary table, those changes will be cached in the IB temp one. That is the main purpose of this file now. Previously, in the 5.7, this file was introduced. Previously, this file was holding all these things. I mean, previously this .ibt concept was not there. This IB temp one is the responsible for all the operations. Okay. But what happened? There is lot of outages due to this IB temp1 because this is a single file that was growing very fast, and you cannot string this file. You cannot string this file, and it will also remove the data once the job is done. The file will keep grow. So only way to string that file is restart. You need to restart so that this IB temp1 file will come back to the old size. Okay, but these IBT files are not like that. Whenever the session is terminated, this file will come back with their previous value. Okay, so let me show that. So here, 1 second. Okay, so um, let's see some example. Where lib MySQL. Okay, let me admit where lib MySQL. So here, if you see, this is actually the within this folder, you might see lot of files, IBT files. Okay, each file having 80 and 96 KB here. Now in the another session, I am creating show tables. Okay, show table. Now I'm manually going to create one table. Okay, show create table MVCC. So create temp TMPOR temporary table. Let's say TS. Okay, TS like MVCC. Okay, so this is actually the temporary table. Show tables. If you see this um, TS table does not show here, right? Because that is the temporary table, but it can be accessed. Now insert into uh, TS, select star from MVCC, limit. Let me insert some 1 lakh record from there to here. Okay, so this is done. Now if you see this size here, this IBT file, which is 13 MB, right? Previously it was 96. What is that eighth file? It was 80 KB only. Now after we insert, it is 13 MB, right? Now, let's say if I am reconnecting, or let me terminate this session. Let me terminate this session. If you see, that same file is now 80 KB again, right? From 30 MB to 80 KB. So these temporary tables are only available for that specific session. So when I reconnect or when I disconnect my session, temporary table will be lost, and you can quickly recover the table size from the IBT file. But previously, this is not the scenario. Previously, this IB temp won't hold everything and it will never stream. Okay, that is the issue before. And here I want to show one more thing. When this IB temp one is going to get, it will grow. Okay, for example, the same thing, use Sri, and let's see, let's monitor this IB temp one. Okay, clear. IB temp1 will be inside your data directory exactly. IB temp1. Yeah, currently it is 12 MB, right? 12 MB. Create temporary table TS like MECC. And I'm going to insert some data. Okay, insert into TS. Let it complete. Okay, this is complete. If you see this IB temp1, now it is increased. All right. If you second, if I am doing ls-lrth. That, one second. Yeah. Um, yeah. So here it is now 52 MB, right? Now, if I am disconnecting here, you can see this comes to 80, the similar to previous example. But if you see this IB temp one, it will still in the 76 MB. Previously it was 12 MB. So when I'm doing insert, that should create the rollback segments. Okay, so that IB temp one size was increased from the uh, 12 MB to 76 MB. But after I come out from this, this got reduced. This session-based temporary tables got reduced. But if you see here, it is not getting reduced. And the only way to reclaim the space from the IB template is restart. Systemctl restart MySQL. This is the only way you can reclaim the space from the IB template. You can see post the restart, the file size is back to the 12 MB. Okay. So previously, this all the operations were holded in the IB temp on, and so that it is fast growing the disk space. Even I also faced many kind of scenarios like uh, around 10 scenarios like with the IB temp on, they got the downtime due to the IB temp on. Then the manually we will restart post that only. We cannot remove this file also. Okay, so the only way to fix that is restarting the MySQL service. Okay, fine. So now you got some idea about this temporary table. What is IBT and IB temp one? And we have this file per table, InnoDB file per table on the specific IBD file. We already aware of it. System table space we already aware. Change buffer we see. Double write buffer and undo log, redo log. The purpose of that we already aware. And this change buffer, log buffer, buffer pool, all these things we already aware. You can see one more thing here is the adaptive hash index. So usually from my experience, I do not recommend to enable this adaptive hash index. But when it is safe, yeah, but first of all let me tell what is that. So we know that MySQL index are using the B tree, right? The traversal, everything internally, it is using the B tree. So when you enable the adaptive hash index, it will build the hash tree on the buffer pool itself to avoid the B tree traversal. So your queries it will be little bit boost your queries, but this will not help for all the queries. Most of the queries it will not helpful. So when it is good to enable is if your queries are repetitive, repetitive with some different value, but the pattern is same, identical pattern. Let's say you are having one select with some where class, some column equal to this, column equal to I mean the same column equal to this. When you see kind of the repetitive pattern of the select statement, then it is good to enable the adaptive hash index. So, and also if your select have very complicated filters, it is not recommended. If your select, if it is repetitive and if it is have very less complicated filters like column equal to or very less amount of in class, something like that, then this will be helpful. We can monitor, like we can easily monitor in the PMM. There is a dedicated dashboard if there is the AH miss happens, or how effectively your adaptive hash index is getting used, that we can monitor. Based on that you can decide whether you need to turn this on or not. But I would strongly recommend to not have these values on the Galera cluster. Usually there is a lot of incidents with this that impact the certification process actually due to the contention inside the buffer pool. So after disabling that, it was helpful from my experience, I'm telling. So that is that. Fine. Now, now here I would like to, yeah. So when it comes to the buffer pool, we need to choose the right value, right? Let's say you have TBs of data, but your buffer pool is too small, kind of very small buffer pool, then frequently it needs to truncate the pages from your buffer pool. It needs to go for a disk, right? Your buffer pool is not enough to keep more pages, right? In that case, that is not exactly about data, that concurrency. Like even you have 100 GB of data, you are reading all the 100 GB of data very frequently. But if you have the buffer pool kind of 30 GB something, again, you need to, your buffer pool. See, all the operations what MySQL do, it needs the buffer pool. Without buffer pool, nothing happens. Whatever you are modifying, reading, whatever, the page should comes to the buffer pool, then only it can process. So having the right buffer pool size will be very good, and it will be helpful to boost your performance. So you can monitor your disk IOPS, how much it is getting used. So you can monitor all these things. Anyhow, we will see that in our later part. Okay. In the performance tuning part, we will see about it. We will address the variables, and we will maybe we will revisit this diagram again. I'm thinking. Okay, that is the one. And we see about this redo log, right? Let's say your read log, let's say you have 2 GB of read log. Okay, 2 GB of read log, but if you are modifying some 20 GB of dirty pages per hour. Okay, in that case, think about it. Your read log needs to, because whatever changes you are doing in the buffer pool, that should be available in the redo log, right? Then only your transaction will get commit. But you are modifying 20 GB of buffer pool dirty pages per hour. But if your read log is too small, then what happened? Because the thumb rule is your transaction should be written in the read log. So in this case, if your read log size is very small, what happened? It in the background flushing, that asynchronous flushing to the IBD file, buffer dirty pages to IBD file will be increased, right? From here to here, it will keep concurrently, it will do this flushing, and it has to remove the redo log. If the redo log size is not enough, it will also signal to wait the queries. Sometimes you may see your queries may getting stalled, even their symbol selects or insert whatever. Maybe there should not be any lock. Everything will be okay, but still your queries are hanging. That is something you need to check about your redo log, all these things. Okay. Fine. So we will anyway we will see all these things in the performance tuning session post the SQL optimization. Yeah. So this is about, I think this session, what I would say is mostly focus on this physical files inside the data directory to get some idea about each the files, so that yeah, Charan.
Hey, Sakti, I have a few questions.
Yeah, man.
Can you go to the structure, like to the diagram that you were showing?
Yeah. 1 second. So I was checking the chat. Okay. Yeah.
So whenever there is a transaction, you
Yeah.
first write, you first change in the, you first write it in the redo log, change the buffer pool, um, and then buffer pool has its own cadence when it writes to disk, and when it writes to disk, it will be removed from redo log.
Mm. Yeah.
When you write a record to undo log is whenever that record is written to disk, you remove it from redo log and you keep it in undo log. So let's say there is a record one that is initially in redo log, and that value is pushed to disk. Now you remove this record one from redo log, and, and then keep that in undo log. Is that correct? This understanding.
No, actually, when the transaction is committed, undo log job is over. Okay. Committed.
Redo log the job is over, right? Yeah.
No, no, no.
Hmm.
See, undo log will keep track the older value so that in case I am rollbacking, it will roll back the previous value.
Correct.
So when I am committed or roll back the transaction, undo log job is over, right? Because my transaction is already committed. So you don't need to keep that record.
Hmm.
Got it? See, I'm updating one row. My previous value is A and I'm updating with B. So underlog will keep track the value A until I commit the change.
Correct.
Un- Until I
And
commit
then
the
when,
change or roll back the change.
yeah, it has A, but when it's
But
committed,
yeah.
when B is committed, B is the new value. So B has to be an undo log so that whenever B is changed to C, undo log already has B.
No, no. But when you are going to change the B, undo log do not aware of it, right? You may change that same time or maybe one day or 1 month later. You can
Okay,
do
in
any
that case,
time.
okay, but in that case, when is record latent undo log?
So once the transaction is committed or rolled back, then so to be straightforward, once the transaction is completed, you don't need to keep track of the particular transaction value because that is already completed, right? So you don't need to keep track of that value. So it will remove it. So whenever the next transaction start, it will track that. Whether it is the same value or whatever, it will track. But you see, let me come to here. So this is my current, I'm updating to A, right? This
Correct.
A1 is needed until this transaction is completed. If I commit, it is fine. It is not needed. It will be updated with the AA. If it is rolled back, then what it will do? This page will be modified with the A1. This A1 value will be served by the undo log. This A1 will be written here. Then it will be rolled back. This transaction is done. No need to keep this value again in the undo log.
I understand that, but let's
Yeah.
say that I have another transaction. Update T1 set name equal to zoo or Apple, where
Hmm.
ID equal to 10. In that case, uh, it's this the previous value of Apple is AA. That should be an undo log already. Who loads that into undo log? When you already clear that value when the previous value is written to disk. So you're
No.
saying that
So you
when
mean
AA is written, it's committed, you write to disk. When commit or rollback is done, you remove the record from undo log as well. Like you no need of A1 now.
yes?
But but let's say the current value on disk is AA. I'm changing it to Apple now, the same record, ID 10.
Yeah, but
At
here
that
the
time,
matter is you are doing this update on the same transaction or the different transaction.
same different transaction, same record I'm saying.
That is
ID
fine.
equal to for ID equal to 10, I'm changing the name from AA to Apple.
Yeah.
Like
So
after 5 minutes, not this, another transaction.
yeah, yeah. So this is one transaction. So you are telling you are doing one more transaction, and here you are changing to
Apple.
Apple, right?
Yep.
Yeah. So in this case, what happened? So first, this value, A1 here, right? Here, A1
Undo
will
log.
be tracked
Undo.
in, yeah, undo. And
Correct.
once this is completed, undo purged. Okay,
Yeah.
undo will,
Undo A1 is not in undo.
yeah,
AA
purge
is also not in redo anymore.
yeah, undo will purge the record for ID equal to 10. Okay.
Okay.
Now after 5 minutes, you are starting one more transaction. So now
Hmm.
what value needs to be captured again? This apple. Okay, you are
AA
telling
should
to
be
apple.
in undo.
Yeah, AU needs to be captured. So AU will be in undo. Okay, once
But
this is done, then it will be purged.
yeah, correct. My question is, how is this AA and loaded into undo log at that point? How will this
No, see, this update state, whenever, see, I think you don't need to relate this, both the updates. Okay, because this is separate transaction, that's it. What underdog will ever, see, similarly, There are lot of transactions going to happen in the concurrent way, right?
He's not even
So
concurrent. It's after 5 minutes or
yeah,
1 hour. Mm.
yeah, whatever it is.
Mm.
So what I'm telling is, whenever the transaction comes in, it will get the before image and it will track in the undo log. That's it.
So you have to go to
So
disk, get the previous value, and keep it in undo lock, right?
yeah, keep it in the undo log. Once the transaction is completed, it will purge. That's it.
But that is inefficient, right? Because you're going to disk and getting it and keeping it undo lock again another disk.
Okay, so in this way, how long this undo log needs to capture this EA value? So you are telling that you will do in 5 minutes or 10 minutes or 1 hour you are doing. Okay, but in some cases, I may do after 1 month. So you mean like until that undo log needs to capture the same value? No, it is not like that. So whenever the transaction comes, it will just capture the previous value. That's it. I mean,
Okay, so you
pre
you go to the disk and get the previous value and keep it in undo
that's it.
log. Okay,
Yeah, once the transaction is completed, it will purge it. That's it.
okay.
Okay. Yeah.
It will be done by any background process.
Which means
I mean, capturing the undo value. I mean, previous value into the undo.
background process means actually for all the operations we it will happen in the background process. We will allocate the InnoDB IO threads and read IO threads and write IO threads. There are this we have the parameters to allocate the threads, how much threads. These all things will be taken care by the InnoDB background threads only. Okay. InnoDB have certain amount of threads, background threads that will be used to track this redo log, write and purge, undo log, write and purge, and flushing the data from buffer pool to memory disk. Everything will be taken care by the background threads. There we have that we can allocate using the InnoDB read IO thread and write IO thread, both of the major parameter. And there is one more parameter, InnoDB IO capacity. So based on that, we will tell, I mean, how much IO of your disk can support. That we will tell use this much of IOPS to work with those threads combined value.
Saktival, one more question.
Yeah,
There is buffer logs, right? In the architecture diagram.
1 second. Which
Log
one?
buffer, log buffer.
Yeah.
So let's say a transaction is completely committed. At that point, we remove that uh, records from redo. Uh, I mean,
Mm,
not redo, but let's say whenever we flush data to from buffer pool to disk, at that
mm,
point we remove the record from redo.
mm.
And when we remove the record from redo, that's when we write it to log buffer. Is that correct?
No, actually, once the pages are modified and transaction is ready to commit, it will comes to the log buffer. Log buffer will send the data to the read log. I mean, buffer the pages, dirty pages modified, the transaction data will be comes to the read log through the log buffer. That way.
Okay, so 30 pages when they're modified, that will be written to log buffer, and from there they'll be written to redo log. That's what you're saying, right?
So once the transaction, so it will get the page and it will modify, right? That dirty page. So now
Yeah,
the transaction is ready to commit. So in that case,
correct.
it will prepare the redo log event and it will send to the redo log. So how it will send? It will send through the log buffer. It will comes to the log buffer, then log buffer will send to the redo log. Actually, the log buffer size is we do not keep much bigger. We usually have 16 MB, 32 MB, 64 MB kind of. Even 64 MB is quite big. We do not keep a very big log buffer. So this is something we are just providing some room in the memory to pile a transaction. That's it. Um, so
Okay.
that it cannot create any contention in the disk. To avoid that, we are just providing some room in the buffer.
And this log buffer is used for replication, right? Point in time recovery, right?
No, no, no.
That's
That is binary log.
oh, those are binary logs. Okay, these are
That
different. Okay.
yeah, this is different. Yeah.
Okay. And what is the purpose of this log buffer? You can, I mean, buffer pools can directly send the data to redo log. What's the need of this? Again, one more structure in between.
Yeah. So this is something we are reducing the contention on the buffer pool, and instead of directly sending the redo log events to the disk, we are having this. Yeah, that's what I'm telling. We do not keep very big size for log buffer. That is very smaller, like 16 MB, 32 MB. That's it. Just we are providing some additional room in the memory to keep the transaction. See, if your disk is contention, then like buffer pool, it may be complicated, right? So reduce that. They have this structure long buffer within the buffer pool to avoid the contention.
Okay.
Okay.
Yes, Siri, I have one doubt.
Yeah,
Like,
buddy.
yeah, while flushing the data from this modified data, while writing to the IBD file,
Hmm.
before writing to IBD file, it will write to double write buffer, right?
Yes.
Those pages. So during that, you told like it will prevent the partial corruption,
Yeah,
page corruption.
partial page, right? Yeah.
For that, let's say how we can like it is we can ensure 100% it will means safety. Let's say
Hmm.
while flushing the data into the double write buffer, that time if instance I mean OS ended database is going to crash, that time that our page will be write to double write buffer. It means 100% that page will write to double write buffer. Always that we can ensure
No,
before writing to
actually,
IBD.
yeah, actually, when your page is flushed from the buffer pool, then you will not get the data from there, right? And see, when like in case if you have any issues on writing in the double write buffer, still you can get the page. I mean, that will go to the complete recovery process to the redo lock.
Okay. And
Okay.
which parameter will means control to flush the data into double write buffer?
Yeah, so we have
If
the parameter
O
InnoDB
direct is there, no means what is meant by that O direct?
old.
O direct that is something is there in this in memory
Yeah,
to.
that is the system call. That will ODirect will bypass the OS cache. It will bypass the OS cache and it will directly flush from the buffer pool to disk instead of writing OS cache and OS cache to from there to here. Actually, that we have different values for that. InnoDB. One second. MySQL. Show variables. Like. Mm, InnoDB flush method, I think. Yeah. Yeah. So this is the parameter you can control. So this is if your operating system supports bypassing the OS cache, then you can use the ODirect. It will improve slightly your performance because you are already bypassing the OS cache, right? So it will give some performance boost. Uh, but yeah, if your OS does not support ODirect, this is actually the system call, like Linux level, fsync, ODirect, all ODirect, yeah, ODsync. These are all the system call. You can use it. But yeah, if your OS support, then you can use it. It will bypass the OS cache from here to buffer pool to directly your IBD. So it will reduce some IOPS and it will give some performance.
Okay, Sri. Here only,
Yeah.
like how frequently it will write to double write buffer. Means some parameter was there to write during the redo log, right? That transaction commit. That
Yeah.
while each transaction commit that will write to a redo log. But
Hmm.
here, while writing to double write buffer, how frequently MySQL will write to that
That
file?
is actually asynchronous. Um, so we have certain parameters. For example, data pages, plus percentage, InnoDB, data pages plus 1 second. Where is that? Let me grab for PCT. PCT. Okay, so if you see this, InnoDB max data page percentage and max data percentage, sorry, max data pages percentage low watermark, right? So this will decide actually how much maximum the data pages can keep in the buffer pool. Okay, let's say if you set it to 10 means 10 percentage, which means if your buffer pool size is 10 GB and you set it to 10, which means 10 percentage of 10 GB is 1 GB, right? So 1 hour, sorry, 1 GB maximum the data pages uh, can be available in your buffer pool. Got this? But
Yeah.
still we cannot completely decide the, yeah, you can set some limit for this sizes, but still the background threads, whenever it has some bandwidth, then it will start asynchronously flush your data from buffer pool to disk. But you can decide how much percentage maximum it can keep in the buffer pool, that you can decide using this parameter.
Mhm. Okay, then with having like a redo logs and a double write buffer, we can say like 100% this will means crash safe, right?
Yes,
No,
correct,
means single transaction also it will not lose
correct.
anything.
So to single transaction, to avoid the loss, I would recommend this InnoDB flush logger transaction commit equal to 1 and InnoDB double write equal to on. This double write buffer you can disable. There is a parameter double InnoDB double write, I think. Yeah, InnoDB double. By default it is on. You can disable also. Disabling that you can save some IOPS. It will help in boost the performance, but not much. But that is not good for your database.
Okay. And Siri, like while crash recovery happen or MySQL is getting restart,
Hmm.
that time while starting the MySQL D, what is the sequence of checking by the MySQL D? Like first it will take to redo or a double write buffer while recovering the instance.
No, actually, it will go through the redo log. So it will maintain the log sequence number. Okay. So if you see the InnoDB status, whatever writes happen, page grab FNI sequence. So engine InnoDB status. Okay, so this is actually the log sequence number. So whenever you are writing something, it will be increased. For example, create database 3.1. Let's see this. This is increased, right? From this to this. So this is kind of the binary log position. So you can just compare in that way. So this all the log sequence, are stored in the read log. Okay. So when you are starting the MySQL back, it will get the final log sequence number, which is updated, and it will start checking the read log. Is there any pending log sequence logs, or is there any pending read log events are not updated yet? Okay, based on the log sequence number, it will check any further logs are there or not. If it is there, then it will start reading from where it left. Where, let's say, if during the crash, if this is your last number, and when you restart, it finds there are some more events, then it will start reading the log events in the read log from this number, and it will try to apply all the pending events in the actual IBD file, then it will get started. So this log sequence, if you want to understand this very much, like you can visually you can see when you are running the Percona extra backup, Percona extra backup or Maria backup, when you are running that, there is a prepare phase, right? Once you take in the backup, you need to prepare it. So when you are preparing, what happened? It will, because during the backup, it will also capture the ongoing transactions in the separate file, extra backup underscore log file. So when you are preparing, it will work on that extra backup underscore log file, and it will apply the missing transaction from here to there. Okay, so when you are preparing the Percona extra backup or Maria backup, you can exactly see what is the flow. It will do read the checkpoint. It will read from here to there. It will apply to the actual IBD file. Then it will start the next set of sequence. It will, if there is any transaction needs to be rolled back, it will be rolled back. So every process will be happen. We will also see that in when we do the Percona extra backup, we will do that in the visual. I can give more details on that time.
Okay, thank you, Jyoti. Here, one more question. Okay,
Yeah, yeah.
sorry. Like while comparing this redo and this data file, means this is here in redo you showed this one is LSN number, right?
Hmm.
You compare header information in data file and this redo log, some kind of that header information it will compare, or how, let's say this 764 in redo log,
Hmm.
same sequence will be there in data file as well, or how, based on
No,
what it will compare?
it will not. See, if it is already we have in the data files, then it is fine. For example, let me show this in more detail. We have no pager, pageless. So engine InnoDB status. So here, yeah. So here you can see log sequence number is this one. Log buffer assigned up to this one. These are all same, right? Pages flushed up to this. Data pages up to this. So everything is same number. So here you can see there is no pages needs to be applied in the um, IBD file. So now if I am restarting my MySQL service, there will be no crash recovery. It will check the statistics. Everything is already up to date. My log sequence number, data flushed up to this. So data pages also flush up to this. This all are the same number. So my transaction is completely now sync. My database is completely synced with the table space, right? It don't need to do any crash recovery if I am restarting my MySQL now. But in case if I am killing the MySQL when there are heavy transaction is ongoing, then you might see the different numbers here. Okay, this dirty pages added dirty pages up to, you might see the difference number here. But this in that case, it will start applying the pending transaction. So what is the any question further here? Like just check.
Hello,
Yeah.
Shri. Uh, you told that whatever we read write is in the buffer for ease of time, so it won't take much time to write on the disk continuously. But
Hmm.
for the temporary tables, the structure remains inside the disk space.
Hmm.
So if we have a bit of work on the temporary tables only, won't it cost much time, or MySQL will take care of taking it in the buffer pool and work there, or we will have to work directly on disk only?
Actually, I think I did not get your question properly. So you were telling
See,
about this temporary table.
yes, it exists in on
Disk,
disk structure.
disk, yes.
So if we want to work on temporary tables, we will have to work directly on disk, or it will be taken to the buffer pool for that time.
No. Actually, if you're manually creating any temporary table, that will comes to disk into the .ibt file. Okay. But if you
Ye-
want to work on any temporary table on memory, then you can choose the engine. You can choose the different engine. For example, there is a memory engine. Okay. Uh, See this memory engine.
Yes.
Okay, so which means your temporary table will be stored in the memory. So if you really want to work on any temporary table on memory itself, then you can convert that specific temporary table to memory. Just do alter table name engine equal to memory. It will be converted to.
Okay. So it's in our hand whether to keep that temporary table on memory or on the disk.
This is I'm just telling the temporary table which you are creating. Explicitly you are creating. Yeah.
Yes, yes, that only.
Yeah, correct.
Okay, thank you.
Yeah.
Shri, I wanted to ask like the data after commit, the data is flushed from buffer pool to the disk.
Mm.
So in the diagram, it is showing like IO direct to system table space change buffer. I didn't got that thing.
So you mean here to you mean instead of here to here, you mean like this?
Yeah, it the diagram shows a system table space like IO direct and then change buffer. So what this means actually, like I understood that after commit it gets flushed, but the diagram this showing that system table space. What this means, like
Um, Maybe yeah. See, if your InnoDB file per table is disabled, it comes to system table space, right? Maybe due to if you extended that arrow, it may overflow. So that could be the reason. But this IO direct is like InnoDB flush method. That is a parameter. It will define the IO direct. This will be used um, to return um, all the table spaces, not only the IBD file. So here IB data one is also one of the table space. That is the system table space that can keep the table inside if the file per table is disabled, right?
okay.
Yeah.
And all
Mm.
and all the like the global temporary tables is like IM TMP1 IBT. These are all table spaces. Okay, am I right? Like
You mean that about general table space?
temporary table spaces like TMP1, IBT. These all are separate table spaces, and the user creates a own table space like temporary table space.
Correct. So when you are creating your own temporary table with create temporary table command, that will be allocated in the .ibt file.
Okay, okay,
Yeah, and IB temp one is the global for all the users.
okay. And like Shri, I have a last question. Like if
Yeah,
the alter or anything is there, does it uses any temporary table spaces in MySQL?
yeah. So we have the in place alter, right? Let's say different types of algorithm we have for alter, right? We have copy algorithm. Copy is the traditional one, and in place algorithm and instant algorithm. So what copy will do? It will block the entire writes, and it will start create one more table, and it will start copy the data from here to there, and it will swap it. That is how copy will work. But this in place is there, right? In place alter. There that um, it will actually capture all the ongoing changes in a temporary file. Okay, that will also be stored in the IB temp1. For example, there is one parameter, show variables like alter. See, InnoDB online alter log max size. So how this is for the online alter, which means the in-place alter. So when you are doing the alter with in-place, let's say your table size is 5 GB and during the alter it is taking some 10 minutes. During the 10 minutes, there should be some writes happen, right? Writes or insert or update, whatever happened for that specific table, right? So during the alter, the changes will not be applied in that particular table. So that instead of that, it will be cached in the temporary file, and at the end of the alter, it will take the small lock and it will apply the changes on the table. Finally your alter will be completed. So for that it will use the temporary file when you are doing the alter within place. So usually in case if you are doing the alter within place, you should increase this size. If you are doing the for long alter something, you need to increase this size so that it will not overflow. Because if this value is overflow, when your alter is running, your alter will get failed. So in that situation, you need to increase this value and you need to um, run the alter. And also one more thing, here you have some when you are come this temp directory. Okay, so here you can see this InnoDB temp directory, and this temp directory, slave load temp directory, replica load, these are the same value is there, right? So here currently our InnoDB temp directory will be used for this online alter. And what I remember in the recent previously, if you see this InnoDB temp directory, you need to set some value, maybe slash temp or some other directory you need to set. And if that during your alter on online alter, if this directory got filled, you may, I mean, your alter will get failed. But recently what I remember, InnoDB temp directory will be your data directory, and the IB temp one file, that on online alter, everything will be stored in your IB temp one file. So you will no need to worry about that alter size. You need to make sure that you have the enough size for this one.
Okay, Shri. Thank you.
Yeah.
Shri,
Srivan.
Shakti will have a question.
Yeah, please.
So, can you go to the architecture diagram?
Yeah.
So, whenever you wanna commit, uh, it is first written. No, no. Whenever there is a write, um, that is written to log buffer. Um, but whenever it hits commit message command, that's when it's moved from log buffer to redo log, right?
Whenever MySQL is by default auto commit.
No,
So,
no.
mm,
What I'm saying is the record will be first written to any write or update will be first written to log buffer,
mm,
and only then it is written to buffer pool.
buffer pool to log buffer.
Uh, Buffer pool to log buffer. Let's
Any,
say
Whi-
if you do that, uh,
mm,
Shri, any parameter we can use for the log buffer. Which
yeah, we
parameter?
have the InnoDB log buffer size. So using that, you can set the value for that. Uh, log buffer. Yeah. So this is the parameter. So I think this is 64 MB. 1024. Yeah, by default value is 64 MB. Yeah, just you can control the size of your log buffer. That's it.
What is the method we control the log buffer size?
What is the method? That's like a, we have the suppose that we have the log size is uh, 16 GB. Suppose we have decide the 16 GB to allocate the log size buffer. So
So,
sorry means I mean log buffer pool size. So
mm,
how can we decide to be evaluate I mean to calculate the value for the log buffer size?
so that is generally depends on your transaction size. Let's say if your transaction size is lower, not more complicated, then the smaller size is fine. But let's say if your transaction size is huge, okay, and in that case, your redo log events will be also bigger, right? So you need to just make sure whether that your transaction is completely fit for the log buffer. That's it. Because if it is not fit, you need the partial thing comes to the log buffer, it will go to read log, then again the rest of the thing will comes to log buffer and it will truncate the older value, then it will do that. Okay. So that may be, but still I did not so far observe any much impact on that point of view, performance related thing I'm speaking. But usually, what I would say is you can decide the right value depends on your transaction size. If your transactions are optimized and lower, then mostly you don't need to worry about this tuning the log buffer value.
And the InnoDB transaction plus commit is the responsible for the commit the data from log buffer to read
Redo log.
buffer.
Yes, redo log.
Redo log.
Redo log.
I
Correct.
mean cache to redo log.
Yeah, correct.
Okay. If
Yeah.
we set the value 0, that means it will be flush in every second. That means might
Flush
be
and
it
F
will
thing every second.
flush.
And F sync.
Sorry.
Flush.
Okay.
Yeah, yeah.
That means we have the some loss, some transaction is not right properly on the redo log.
Of course. Yeah. Due to
Okay.
any case of crash, there is a high chance of losing the transaction.
And the 2, if we set the value 2, then
Hmm.
what happened?
Two means MySQL flush the data to OS. So in case just your MySQL crashed, then still you can your OS will take care on doing the fsync. On a second, it will do the fsync and it will flush the read log. But if your OS also crash, then still you will lose the transaction even with the value 2.
That means we always set the value as a 1.
Yes. So if you want to ensure that zero transaction loss, you should keep it 1.
Okay. Sometimes we getting the replication in my environment, in my production environment, we getting the some issue on the replication server. It will be behind from the master more than the 10 minute. Then we set the value as a 2 and it will be sync within a 1 or 2 minute.
Yeah, that's
So
what I
it's
tell, right? See, 1 means you are, see, I think last class I said one example, right? 1 means, let's say 500 people are waiting for the bus stand and
mm,
bus comes and one trip, one guy. Then the bus needs to do 100 trip, right? But
yeah.
that is the one actually. For
Okay.
every transaction, it will commit.
Mhm.
So every transaction, it needs to spend the resource. I works all these
Okay.
things.
Okay. Okay.
Yeah, yeah. 0 or 1
Thank
means
you.
I can
Yeah.
group and commit. Yeah.
Okay.
Yeah,
Thank
Shri, I wanted to ask like the MVCC in it is applied in MySQL.
Yeah.
So how like once the row is changed, like undo thing is recorded, like the transaction is recorded in undo, previous like previous record which will be updated. Then how the select will identify the old record and like how the process would be like for MVCC.
Yeah. So that is actually the issue. Like when we have the uh, the record in the undo log. This rollback segments, everything will be stored in the this one only. Okay. What is that? Undo
Undo.
log.
Yes.
Now let's see. I am writing. Let me show an example. We have time, right? Anyhow. So use 3. So here I have one table. Maybe I'm audible.
Yes, Shri.
Okay. Power gone. Not sure, man. Sometimes if the power gone, Wi-Fi out. Sometimes it is not happening. Why? So I'm still audible, right?
Yes, Shri.
Okay. So this will be interesting thing. So that will actually impact the performance, man. But still the record will be there. Same record will be there. Let me show that in examples. So this is one of the table. Okay. So I have this. And if I am doing select star from this limit 1. So select name, comma, count of star from MVCC group by name. Okay. Let's see how much time it is taking. See, this is taking 2.884 second, right? Now here, what I'm going to do, uh, um, yeah, watch MySQL -e show engine InnoDB status /g grep -i history. Okay, so currently the history length is 0. And here what I'm going to do, where lib MySQL ls-lrth undo. Okay, undo is 16 MB, 16 MB. Now, and here you can see this select is taking 2.85 second. Now I'm starting the transaction here. Begin. Okay, begin, and I am running this select. So within the transaction also it is taking 2.81 second. So if the MVCC work, then if I am modifying the row in the different session, then it should not. The select should return the same result, right? So with the repeatable read, I already started one transaction and I executed this select. So this transaction should return the same result if I am modifying something else. So in this session, what I'm going to do, 3, okay, update, update, uh, update MVCC set name equal to e where name equal to e. So overall, how much data? 1, 2, 3, 20 lakh something data is going to be updated when I'm running this update in the different session. Okay, let it run. So as usual, when doing this, if you modify the undo log, you can also monitor this guy. You can see the undo log is keep improving, right? Because all the changes should be written in the undo log. So you can see the undo log size is increasing. Now let this update complete. I already have the index name. Still, yeah, my voice is just one core. Still, it is long, man. Let me admit. Okay, I'm not sure how much time it is going to take. Come on.
Yeah, it is too much records. It is almost 20 lakh records.
Yeah, yeah.
I think index is not created on the name column.
Yeah, it is done. Fine. So now you can see this is done. And if you see history length is increased, right? 2. Now if I'm running this select, you will get the same result due to the MVCC, but see the difference in the query time. Previously it was 2.81 second. Now it is 12.99 second.
Oh,
Because when this update started, this undo log size was 16 MB. So this MVCC, I mean this select snapshot was captured at the 16 MB. Now when I am executing this same select again, this select needs to be travel before
Oh,
this value, right? But
yeah.
still it keeps it keeps the snapshot because you see this is changed. But you can see this EE is the same result, right? So this is how MySQL keeps the multi-version. But but if the transaction holding long time, if it is the bigger transaction, then this will negatively impact the tran statement time. Now, if you see, let me commit this. Let me commit. Now I am running the select again. If you see this select, it is 3.72 seconds only because this transaction is completed. You don't need to keep the snapshot, right? It will get the fresh snapshot in the other transaction. This is the new transaction. So it no need to keep this transaction and it no needs to go to this data, right? This is how it works, man. This MECC thing. MECC works, but this performance could be the problem. It will keep maintain the older data, everything in the undo log itself. But in that case, that is actually the good question. When we have multiple thing, it will definitely impact the performance, as you see here. This
so
makes
like
sense, right?
every
Yeah.
yes, yes. Like undo 002 will be removed right now, right? Then the
This
undo
will
0.
update in rolling manner, undo logs.
Okay.
Yeah, yeah. So we have certain parameters to define how much undo logs, how much undo log size, all these things. InnoDB
Okay.
undo table spaces, InnoDB undo size, things we have.
Okay. So every statement is recorded, like select, insert, update, delete, everything will be recorded in undo.
Yes, correct. So
Okay.
undo will have this snapshot for MECC as well as the rollback segments.
Okay. And the history list, like what it shows, like I didn't got it. History list.
History list length means how much history currently this undo log is maintaining. That's it.
Okay, like only one transaction it is maintaining right now, like update query.
Yeah, yeah,
That's
right.
okay.
Sri,
Yes.
um, so whenever whenever the record is removed from redo log, that's when it is written to bin log, right?
See, whenever record is removing from the redo log, which means your data is already in your table space, I
Committed.
mean data IBD file, as well as in the bin log.
No, what is the order there? I mean, once your data is written to disk, you can remove it from a redo log.
Actually, we are not going to remove from read log. So the flow will be that to control the sync bin log writes, you have the parameter sync underscore bin log. So similarly, like a InnoDB flush log a transaction commit value, if you set sync underscore bin log equal to 1, which means for every transaction commit, it will write the bin log.
Okay,
Okay,
for every command it will write okay,
it will be
bin
written
log.
in the bin log. So whenever your transaction is already getting written in your read log, that say time itself, it will be written in your bin log as well.
Got it. Okay.
Hello.
One other point,
Yeah.
let's say you modify the data in buffer pool and then you write it to redo log, but the data is not committed yet. And then when there is a read that comes, it will read this dirty data and it will read the dirty data, right? Like in the when you're doing snapshot isolation or serializability isolation, how do you handle this situation?
I did not get you. Can you please repeat?
Um, so basically, there is a update to a record. It is
Mm.
first written to buffer pool and to the in-memory log buffer and then to the redo log.
Mm.
No, no, sorry. It is not yet written in the redo log. It just is written to in-memory buffer pool because we haven't reached the commit statement yet.
Mm.
At this point, there is another transaction that wants to read this record. It will read this the data, right? In
No,
buffer pool.
that is completely depends on your this thing, right? Isolation levels.
Isolation. Yeah.
If you set isolation level to read uncommitted, then it can read the dirty data, dirty page, dirty
Okay.
reads. Yeah. If you set the committed, then it should read the committed data only.
But how does it know it is committed or not when it's in memory?
No, actually, when it is memory means it should be also in disk, right? In the reader log.
Correct.
Yeah.
No. When it's in memory, and let's say there are 10 statements before commit, you're executing the statements, the commit is not yet done. It's in memory, but it's not in redo log yet. That's when the read comes, uh, it will read this dirty data, right? Even if I set the isolation level to serializability, but in memory, this data is already, I mean, dirty data. It has to go to disk and get the fresh data, like uncommitted data.
Actually, if your transaction is not in the reader log, your transaction is not committed. If it is
Correct.
there in the reader log, then it is committed. That's it. Based on that, your isolation will be treated. The
I
isolation.
agree.
Hmm.
But when a read comes, will
Re-
it directly be read from the buffer pools, or you will first check, okay, whether read log and see, okay, whether this is committed or not, and whether I should really be reading this.
No, no. Read comes. That is a separate transaction. So I am not correlating to here. So when the read comes from the different transaction means
Hmm.
it will rely on that isolation level only. See if it is committed or not, whether it is in read log, that is never mind up, right? That transaction will never mind about it. When it comes to the MySQL, it will based on your isolation level, the transaction will behave, right?
Yeah,
Uh,
I agree.
yeah, I cannot correlate that.
Now, my point is,
Mm.
in buffer pool, you have some data loaded from disk into buffer pool. There is a page in buffer pool, right?
Dirty page.
Initially there is a page which is
Mm.
not yet modified, and
Mm.
then you make some changes in that page, one record. It's
Mm.
30 page now,
Mm.
and we haven't written that to redo log yet because redo because you haven't hit the in the Java code you haven't hit the commit statement yet, or no, so you haven't written
Okay.
the redo log. It's
So
still in the
that
buffer.
page is just modified.
The page is just modified. At
Mm.
that point, if there is another transaction T2 that wants to read this record,
Mm.
how does that T2 know that okay, this record in the buffer pool is not yet committed to the buffer pool, redo log? it has to check the redo log. Only then it can know, okay, this is already committed, so I can read this.
See, so let's simulate that. I'm still confused. So here we have begin. Okay.
Hmm.
So before that, let me check what are the tables I have. This MECC is bigger one. Select star from yes. Oh my. Fine. 1 second. Okay. Select star from mm, T11. Mm, T5. Oh man.
Siri, what I understood, let's say single page also contains multiple rows, right? If that
Yeah.
page is already constrained that buffer and next transaction came and is searching the same row from that table, that time that new transaction can read those rows or not? Like that he might ask.
Actually, it should not
Right.
interfere. So that I want to explain in the terminal. So what who were asking? Sharon or
Sharon.
yeah, yeah. So Sharon was telling. So here there is one begin. So update, right? Update Sri set name equal to a where id equal to 1. So this is done. But Java code does not trigger the commit, right? So now you what your question? So there is another select coming, right? So
Yeah,
currently this is in the dirty page. This
correct.
value is in the dirty.
Hmm.
Now the another transaction is coming, and they were trying to read this value, right?
Correct. ID1.
Id equal to 1, they were trying to read.
Hmm.
They should get this value. Select, use, sorry, what is the database? Perk. Use perk, select, star from Sri where id equal to 1. They will get this value.
Okay. Is it because MVCC is
This is
uh,
because this one, isolation level. We have repeatable read, right? Let's
hmm.
say if I have, for your scenario, let me roll back this. Only if I have set global transaction underscore isolation equal to read uncommitted. If I have this, let me reconnect here as well. Uh, begin. Let me select star from Sri. Okay, I have the similar value. Begin, update this EA, right? Now, if I do this select, I will see the modified value. So this way, this is completely, it will be based on your isolation level.
I understand it based on isolation level. My question was, how does MySQL track it internally? Because this AA is modified in buffer pool, w- right? When you said update ID equal to 1 to AA, it is modified in buffer pool in memory.
Hmm.
But another transaction when it tries to read, like read from the same row, if it reads from memory, right now it will read that e value. So it has to go to disk and read the value and come whenever for selects. Or the other way is it should refer to redo log and see, okay, this is
No,
in
no,
memory is
not redo log, undo log, right?
oh yeah, oh yeah, it can go to undo log and check the
Yeah,
previous value and just get it right.
correct.
Okay, that's what I was asking.
Okay, okay, yeah. Cool. So anything else, guys?
Yeah, on my last question, Sri, uh,
Yeah.
while any user is a firing command like a select command. That time, let's say select select something from EMP and employee
Cell.
department equals something like a HR, right? There it will be number of rows, multiple number of rows.
Mm.
So, like while making the plan in MySQL, that optimizer that will check the how many rows and how many columns those stats information it will capture during the plan rebuild, right?
Mm.
So in MySQL, like that statistics table will be permanent, or like that information schema dot statistics means that is not permanent table, right?
Which table you are referring?
That whatever number of rows and number of table record will capture by the information schema dot statistics, right?
Mm-hmm.
That table will be permanent, or that will be the virtual, where it will store in IB data one. That
That is,
the question is like a system related, whatever statistics related records, where it will store in the IB data one, or in.
no, this statistics mostly we will track on this MySQL IBD, right? You are seeing my screen, right?
No, you are showing only.
Okay, okay, I disable the screen now.
Mhm.
No. Yeah, screen is visible.
Yes, yes. Now
So
it's
actually,
fine.
this is the table will calculate all the index stats. InnoDB underscore index underscore stats. So this will have all the statistics about your index, cardinality, all these details. And this is located in the
Nice.
MySQL database.
Okay, then number of rows, how many number of rows in that T1 table, that where it will be?
T1 table. That is on the information schema dot tables.
The tables.
Yeah, there we have the rows column. It will track the rows of the rows in the table. Yeah. See,
But that information schema dot stats, that is permanent, persistent record, right? That
yeah,
is a.
that is actually the system. One second. System created database. For example, if you see inside your data directory, all the databases, you will have the folder. Performance
Correct.
schema, MySQL, everything. But for the information schema, you do not have any folder, right?
That is
And
not there, right?
you
Yeah.
cannot modify any any tables inside the information schema. So this is all from the data dictionary, which is stored in the IB data one. So that will be populated when you start initialize your MySQL. And the tables all are available inside the information schema that are mostly views that will just to maintain the metadata of your database. The
Meta,
location. Mm,
yeah, metadata, or that, let's say one table we have T1 and T2. If
mm.
we modify the structure, and we added some columns, or we updated some 10,000 rows, that latest record, whatever 20,000 rows in that table, and new column added, those statistics information will store in IB temp one, right? Not temp, IB data one, system table space, right? Those kind of statistics related records.
Statistics related
That means you will
records will
say that
be
here the metadata about. I mean, you will add the column, any column, any table. Data will be stored on the IB data. That means ki information schema. But you will update the data. It will be not stored in the IB data. IB data store the metadata information
Yeah,
only.
that is correct. Whatever I updated the records, that will go to physical.ibd file, that I know. But metadata information, let's say T1 table has 20,000 records. That information will need to keep by the uh,
IBD.
no, the records will be there in IBD, but
Yes.
metadata information, right? While making plan, that time if we are selecting a record from any table T1, that time how this optimizer makes a plan means it will think, right? This table has this many records. Means it will take from the system table issues or somewhere else, right? From the metadata before creating the plan.
But
Y-
here, I think she in the 2008 .frm is not showing here, no?
which one?
Suppose that we have created the any table,
Hmm.
and before the 8 we have the two directories shown on this data directory. One is the .frm and another is the .ibd.
Yeah.
IVD store the data and .frm is store the information about the metadata like index, table structures, and the other things.
Yeah.
But in the 2008, we I think no show here, no? I
Yeah.
mean
So actually, from MySQL 8, the .frm files are completely removed.
remove.
So we will have only .ibd file, but in the ibd file, additionally, it will store the SDA informations. So we see that in the last session, maybe you can go through it. We completely see no FRM, and instead of we have the SDA that will be stored in the .ibd file, and you can extract the SDA informations from the .ibd file using the ibd to SDA tool. That just go through the last recording, you will get the detail there. And regarding the Pandit that you were question man, so we have certain system tables that everything we have in the information schema. Okay, so inside the information schema we track all the metadata about your data and the structure information schema, right? So here you will see all your optimizer related tables. For example, InnoDB statistics, InnoDB, where is that? Um, InnoDB,
Columns and tables.
yeah, for columns, InnoDB indexes, right? And also inside the MySQL, we have the InnoDB index stats. That is also one of the table. So this will keep the uh, data up to date. Okay, let's say if you are adding one table, then you will find the information about your table inside this table. For example, let me do one thing, select star from uh, tables where table schema equal to 3. Okay, so here you can see all the tables. There are overall 3 tables inside the database tree. So they here you can see the informations about your tables. Table name T1, whether it is base table or view, which engine, which row format, and how many rows. All these details will be captured here. Okay, here you can see this is one of the bigger table MECC which is created. Table size, index length, right, and table rows. This is I think this is the one you were asking. How much table rows? This all details will be available in these tables. Similarly, you have the other tables as well. If you see this columns table, there is one more table which is columns. If you see this table, actually here you will see the information about your table, right? If you go to this table, here you will see the information about each and every column, the detailed information, right? And there is on InnoDB indexes, FT index, index cache, and InnoDB indexes. So if you see this table, you will get all the statistics about your indexes. So how optimizer will choose the right index means optimizer have some certain settings. The parameter optimizer switch, there it has some certain settings. Based on that, it will check the cardinality on the mysql.innodb stats. Okay. For example, let me go more clear on this. Show tables. So cardinality is one of the main thing. Select star from C. So here, let me pick this table, MVCC. Okay. Database name and table name. One second. Where table name equal to MVCC. Okay. So if you see this value, yeah. So these are all the secondary index, right? Let me describe this table. Show create table 3.mvcc. Okay. So ID have different column value. MVCC primary name, ID, number of leaf pages in the index, number of pages in the index, and show index from MVCC. Yeah, so this is the primary key. This is the MVCC. So actually here you can see for the each column, you will see the cardinality value right here. Cardinality value and the column name. Actually, in this table, we have two major indexes. One is the primary key and the key is the secondary index. Okay. So primary key means primary key means we have that does not allow any duplicate, right? It will not have any duplicate. So each and every row will be the unique value, right? So it has a higher cardinality here. But if you see this IDX value, that name, we have the different values and the repeated values. All are the repeated values, so it has the lower cardinality. So how the optimizer will choose the indexes is, let's say if I am doing one scan, uh, scan based on the ID column here. Okay, based on the ID column. So you are available, right, Pandey?
Yes, Sri, yeah.
Yeah, one second. Let me create one clear example so it will not confused. So create table T1. Let's make ID int primary key. Primary key. Okay. Then name one. We can have varchar 16. Then name two varchar 16. And yeah, it's fine. What happened? T1 already exists. T100. Insert into T100 values 1 comma A comma A comma B. Okay. Now similarly 2 comma A comma C. Okay. And now 3 comma A comma C. Okay. Now alter table T100 add index IDX 1 IDX 1 name 1. Okay. And IDX 2 name 2. Okay. Now show create table T 100. This one. And select star from T100. Now show index from T100. Okay, so now if you see this, 1, 2, 3, primary, cardinal T1, but the primary should have this, right? Alter table. Better let me do optimize table T100. Okay. Really not sure. So, but Control L, select star from and show index from this. So here, if you see this index IDX1 and IDX2, here you can see this. Actually, the name one column is the having in the IDX1, right? Show
Yes, IDX1. This cardinality should be 3, right? This
primary key.
for the ID.
Yeah, that should be. I have to check why it is 2. You need to 1, 2, 3, 1, 2, 3. Null value is. Let me check 1 second. Select star from MySQL InnoDB index stats where table name equal to T100 inside the tree. So IDX1 3 primary 3 1 1 diff prefix is 3 1 1 and select star from information schema dot statistics limit 1. Let me do index name. So here, let me tune this. Select table name, comma, index name, comma, cardinality from information schema statistics, where table name equal to T100. This also display.
Means stats are already updated.
Sorry, can you repeat?
This stats already updated means this cardinality should be 3, na? Means that ID wise. ID 1 to 3 was their record, right?
Yeah, 3 unique value. It should be 3. You need to check then, man. Why it is not?
Okay, not an issue. My question is here only, Sri, like information schema dot stats is kind of views, not a physical table, right? They should refer to some base table, na?
Correct. So we
That
have certain parameters, DB
okay.
stats, persistent.
Mm-hmm.
So we have certain parameters. Based on that, it will update the statistics
Okay,
on
okay.
the
Yeah.
table, and that based on that, optimizer will choose the index.
My question was there only, like if we are changing records in table, that statistics, live statistics should update where on that base table in IB data one or this information schema dot stats
Yeah,
statistics.
it will be updated, man.
So always this statistics will refer to somewhere, right?
Uh,
Information schema dot statistics.
correct. Yeah.
Okay. That actual my doubt is, where is that real physical data? This is a kind of view only.
Yeah, yeah. So actually, this will be reside in your IB data one.
IV
So
data one.
yeah,
Okay.
IB data one will have the dictionary tables
Okay.
and the change buffer and the metadata of these tables. Everything will be stored in the IB data one. So
Okay.
this,
Thank you.
yeah, yeah, yeah. But this is pretty weird to me. This primary, why it is too interesting. Yeah,
Yeah.
maybe I will get
I,
back more on this this one. Okay,
thank you, sir. Yeah. Yeah.
tomorrow.
Sorry. Today it's too
No,
long.
no, no issues, man. Cool, cool. I
Bye, sir.
think we can wrap up. Let's connect tomorrow. Okay.
Yeah. Thank you.
Thank
See
you.
you.
Bye. Bye.